Good morning, my friends. This video is about building a small DC alimentation derived directly from the AC source. To be able to build this alimentation, we need principally the alimentation source. So you can no, not this one. Yes, this one. So you are seeing the alimentation source. We check in the first place if we have the 220 volt. So we use a multimeter to check this voltage. So we came here and we check. So we see that we have an alimentation of 243 volts. 243 volts RMS, which is about 340 volts maximum value. In the second place, we need to drive this alimentation source. We see it here. You can see it here. We drive this 240 volt AC, where we use it at the entering place of a transformer. You can see it here. Here we can see it. We are using a transformator. This transformator, the way you are seeing it, is connected directly to the AC source. So we have here 240 volts RMS. The output of our transformator, look, we have a transformator with a neutral in between, and we can say we have minus 16 volt and plus 16 volt in certain way. For our alimentation, we need only a tension between 0 and 16 volt RMS. So we derive this tension and we put it in our each main plug. We introduce the tension here. You can see it better. You can see it better. The tension, you can see it. The tension is from the input of the tension is right here. We have our 16 volt AC that are here. These 16 volt, we introduce them to the plate. After that, we derive this tension and we use it to the input of a bridge. This bridge is used to rectify this bridge is used. It is the B380 bridge. It can take I think to 500 volts, but we use only 16 volts as AC as in input, and we have the rectified wave. The plus is here and the minus here. At the output of this bridge, we connect a capacitor, a chemical capacitor. This capacitor has a tension about has a value about 1000 microfarad. So it is used to reduce the ondulation of the signal after the rectification of the wave. After the output of the capacitor, we use a regulator. We use the 12 volt regulator LM7812. So we put it here. We put it here. The input will be the non-regulated wave, and the output will be the regulated wave. So we check if we have 12 volts at the output of this circuit. So we came here and we use our multimeter. You can see the multimeter. So I measure between the output and the base, the ground. You can easily see that we have 11.65 volts. So we have about 12 volts DC. So the input, we began our work with a 200, and we began our volt with a 240 volt AC, and we were able to generate a 12 volt DC. We need to check if this alimentation works. The simple way is to use a DC motor. It's very easy to use. You can see it. This is you can see it. This is a DC motor. You can see it. We connect this DC motor to an ampere meter, so we can measure the current that is currently traversing our circuit, so we don't overheat the LM7812 regulator. So we check if we have correctly connect our. So we element the motor. So you can see here that the motor is rotating. We can put some a load. You can put a load to check, to have a better visualization. For better visualization, we can see we connect here. We connect here. So, and you can see we have the load rotating, and in the same time we can check the current, the value of the current, and you can see that it is about yes, you can see that it is about 2 amperes, 2.6 amperes it should be. So you can see it here. So I'm showing you the. Is it correct? Yes. So from this circuit, what we have here, the AC alimentation 240 volt, the transformer that have a transformation rate of when you use the half wave 0.07. We have the bridge. We have used the B250, and the regulator LM7812. Before it, we have the capacitor of 1000 microfarad and at the output 10 microfarad. We connect our DC motor. So we connect our DC motor here, and we launch the simulation. We can see that at a certain rate we have the rotation, the speed, and thank you very much. And I hope I will share other videos containing treating other type of alimentation.